everyone. We're here today to talk to you a little bit about how design and engineering come together to make a fantastic drone delivery experience. And today I've got Kieran and Stephen here to talk to us about it. Would you guys introduce yourselves?
Sure. I'm Kieran. I'm an industrial designer specializing in packaging design here at Zipline.
And I'm Stephen. I lead the Droid mechanical design engineering team here at Zipline. Yeah.
Thank you, guys. Okay, to start, we're going to talk about the Droid. So the Droid is a unique part of our delivery experience, and it has to handle a lot of different challenges. We're delivering food, we're delivering medicine, we're delivering groceries. Could you first tell us a little bit more about how you think about packing all those things in the Droid and making sure they arrive in good shape?
Yeah, sure.
Should we walk over here?
Yeah, so as Kelly mentioned, this is the Droid. So the Droid is one part of our aircraft system. So this is the delivery vehicle that is lowered down to the delivery site, while the primary aircraft, which we call the Zip, stays about 100 meters up. The purpose of this is we can deliver all kinds of goods with kind of the same amount of care as you would be placing a bag of groceries on your front step. So, you know, we can deliver delicate items like eggs, we can deliver temperature controlled items like prescription medicine, as well as all kinds of takeout food, with a lot more consideration than maybe, you know, a 10-foot drop right above your driveway. So the way I think about filling out the Droid and kind of maximizing what we call the payload bay, we think about forms that can nest into each other. For the most part, tipping and spilling aren't major concerns. We've done a lot of flight tests, and primarily standard packaging works in the majority of cases. So we want delivery partners to be able to use their existing packaging, and it's only in rare instances that we might need to design something custom. So that's why we're going to be talking about the pizza box in particular later today. But for the most part, you know, very familiar packaging forms will work in the Droid. And the kind of a good frame of reference is if it fits in a large grocery bag, it will fit in the Droid.
So how have you gone about thinking about the prototyping when you do have to do custom things, like, you know, for instance, like a whole pizza doesn't fit in there? So what has been your process for coming up with solutions?
Yeah, and I'll kind of describe the design process in general. And this is a process that can be applied to any problem. And I like to say if we can clearly articulate the problem, the solutions become evident. So the design process in general is kind of the way of working through the ambiguity of kind of the challenge or the problem space, trusting the process and going through iteration to arrive at a desirable and manufacturable result. So generally, the process starts with sketching. These are just some thumbnail sketches in my notebook for kind of trays and inserts, little kind of buckets for the inside of the Droid. Thinking, you know, if we had a certain delivery that would benefit from keeping the contents contained, maybe stabilizing the base a little bit, we might want to look at a molded fiber kind of material in some kind of custom geometry like that. Another example of, you know, a custom concept is we can fit a 4-drink carrier and a 2-drink carrier in the Droid. So does that warrant developing a larger 6-drink carrier? Maybe. The process in general, as I was saying, starts with sketching for me primarily. Starts with sketching, just kind of quick iterations of form, details, thinking about construction, manufacturability, user experience. So these are just kind of general reference for, we have some rigid boxes, some bags, some trays, and as we're sketching, we'll be considering, kind of how that final product will be produced and then what benefits it confers to the user. So, for example, we think about kind of ergonomic affordances like handles or mixing materials if we want a paper handle mixed with a more rigid insert, things like that. So from there, we go into 3D prototyping. And so that takes a few forms. We do a lot of 3D printing. That's pretty familiar to folks. And then for flat packaging, we do a lot of laser cutting. So that starts with lower fidelity prototypes just out of chipboard, line work that I generate through Rhino or Illustrator. I can laser cut those, and then these can be folded up into a three-dimensional structure.
Are there particular materials that you're like, what are the considerations you're making related to materials? Like, I know sustainability is important to Zipline. Are there things that you're factoring in the design process along the way, or at least in like the end product that are more sustainable?
Yeah, definitely. So we would like our packaging to be as sustainable as the system as a whole. So it's my goal to use only paper. I like to kind of set that as a challenge. Only paper-based materials, and try to avoid plastic as much as possible. This is maybe more realistic for, say, like takeout food packaging. We'll have healthcare partners where plastic packaging is a requirement for, you know, safe and secure delivery. But when we are thinking about custom packaging for, you know, food or consumer goods, I like to really just focus on paper-based products because they're renewable, they're compostable, they're biodegradable, and they have a lot of great properties. You can, as I was saying, you can mold them and get, you know, rigid inserts. You can fold them up, get creative kind of shapes and tessellating forms.
And lightweight too.
Yeah, exactly. Yeah, thank you. Yeah. As everyone is reminding me, mass is a big consideration.
Mass is everything, right?
Yeah, exactly.
Well, while we're talking about kind of like, you know, some of the specific requirements, I think temperature is really important. So I'd love to talk about how you how you think about that. Mm-hmm. You know, and Stephen also will have questions for you about how the Droid helps us keep things the right temperature. But first, on packaging, we've got a little bit of a test to set up here, right?
Yeah, so we're going to set up a test that will just run in the background while Stephen describes the construction of the Droid. A lot of people ask about delivering something hot and cold in the same Droid, and so we want to kind of show that in most cases, for as short a flight as most Zipline customers can expect, under 10 minutes, that no special packaging would be required. So we're going to bring in some piping hot pizza in our special Zipline friendly pizza box, and combine it with some ice cream and just kind of let it sit in the Droid to simulate a flight, and then upon delivery, you know, both will have maintained their ideal temperatures.
All right, we're going to have our assistants run around and get a pizza.
Yeah.
So while they're working on that, I have a few more questions for you just about some packaging things on the topic of temperature. Also, you mentioned that we don't need special packaging. Could you talk a little bit about in the healthcare use case? Like, I know from personal experience that there's a heck of a lot of like cold pack and things that often come with specialty medications. Mm-hmm. Is, you know, like, I'm curious how we're going to do that for healthcare where, you know, maybe you need less of that, but you're closer to this than I am.
Yeah, exactly. So the great thing about Zipline is, from a packaging perspective, we're not beholden to the same constraints generally as ground transportation, right? Ordering a delivery is almost instantaneous. The delivery itself is only a few minutes. So the cold chain requirements from a packaging perspective are a lot lower. That's not to say that we won't use insulative packaging or cold packs as needed to just maintain an ideal temperature. But this is different from, you know, a ground transportation delivery where we might need, you know, really heavy-duty, multi-layer insulative packaging, or, you know, dry ice, for example. So
important to note, these are like direct to consumer. So, you know, like, it's only the consumer that gets their delivery.
Yep.
So
There's no stops. Right.
And it's like, you know, sub 10-minute flight. We enable that with like high-speed forward flight. And, yeah, that's basically the key enabler here to not require all of this sort of excessive, undue, unnecessary packaging.
Yeah, it's pretty unique.
Yeah.
Well, while we wait for our pizza to show up, which we'll have to look at for this test to be legit. Stephen, why don't we talk a little bit about Do we want to look at this droid?
I'd say we look at this one up here.
Okay, we'll walk over
we kind
there.
of had this one prepped up.
So on the topic of temperature, last question on this is just like, I'm curious the features of the droid itself that might like make it a great experience for consumers receiving, their hot pizza or their ice cream. Are there any features that are built in?
Absolutely. The key feature really is it's a flying cooler, right? Like it's made of the same materials. Like a lot of the same sort of like design criteria are kind of used. Like it has this sort of insulative exterior, this like hard shell sort of interior that interfaces with the payload. And very importantly as well, these doors close. Perhaps they could be closed for us here on command. And they provide like a reasonably tight seal to any airflow or so any kind of forced convection.
Look at that.
I know, right? This tether is necessary to do that for the moment, so that's why that's there. But yeah, they're the kind of key features that enable that. Yeah.
All right, tell us a little bit more about like
the concept.
I like hearing that this is a flying cooler, but I know that it's like a lot smarter than that.
It certainly
so maybe
is.
You could talk just like generally about some of the engineering that's gone into.
Absolutely, yeah.
Should we pause?
Yeah.
Should we pause for a hot pizza?
Yeah.
Okay, we'll come right back.
Takes priority.
Okay, popping. That looks pretty good.
Yeah. So we've got pizza fresh out of the oven. So we're gonna load that up, and you'll see the reason for the shape of this box. The reason kind of the profile fits that circular pizza is so that we have space on either side of the box for cylindrical containers, so drinks or ice cream. So I'm going to load these up, and then we'll check in
and
a little
we'll
bit.
set our timer for a long delivery, which is not even
The longest,
not
in fact.
the
Yeah.
average.
Yeah.
And see how it goes. And as a pregnant person, I feel like I'm the best judge of whether we succeed this test. All right, we'll check back on that.
Awesome.
All right, Stephen,
Okay.
tell us more about the engineering that goes into this vehicle.
Right. So yeah, like we were saying, it's far more than a flying cooler, right? This really is a delivery aircraft in itself. So yes, we attach it to the aircraft above, but this needs the ability to perceive the environment around it, to control its own position. Like it really is an aircraft unto itself. Just without the ability to like translate up and down. It relies on the sort of mothership zip for that. But it needs all of the safety features, it needs all of the perception features, it needs its own battery, its own thrusters and everything to navigate the world. So what happens is, maybe I can even show you this guy. Yeah.
Show us some
So this is
come over here too.
this is like our sensor suite and infrared illumination source. And this is basically scanning the delivery side. So it's a kind of, before every delivery, the user will have sort of like pre-scanned their yard or their front porch or something. And it's trying to make out the features that it saw in that scan and trying to pick like the flattest, most reasonable spot.
Okay, so it's like I want it on my patio table, or I want it, like on a grassy spot.
Yeah.
Well,
it'll tend to kind of,
and then find it.
exactly. It'll tend to kind of seek out that flat, grassy spot. Like obviously we can't just say, oh, it's flat, we can deliver there, because there's pools, pool covers, like plenty of other things we need to avoid. And right now we're collecting like a lot of data and basically feeding this into learning algorithms to
So there's all the software
Yeah.
too that's like going
Yeah,
that's behind the scenes making this work well.
the software effort is definitely larger than the hardware effort.
I know
I
you
would
probably
say
don't
that.
have time to like get into it today.
For sure.
What else was I going to ask you about? Okay, so we talked about like sensing and perception, and you also mentioned it can like avoid things. So
It certainly can,
like,
yeah.
My 2.5-year-old's going to run across the yard because this is very cool, and it's what happens in that scenario?
Well, we have this like super wide angle sort of lens that's able to capture that. Like so, even when it's pretty low down, it's able to kind of see people kind of moving around it. And it obviously won't perform the delivery if it perceives a threat.
Right.
And if it does, like we have all these kind of guards and safety features.
Okay, so if you want your pizza, keep your kid away from
Absolutely,
the
yeah.
droid. Okay,
yeah.
very good.
We also know where you live, like if it's abused and such. So
That's true. So tell us a little bit more about, maybe you can kind of walk us through like the end-to-end experience for a customer. Like I'm placing an order, what should I expect?
you will expect
To
this thing to So you expect a notification on your phone to tell you that delivery is imminent. The zip will hover overhead at 100 meters, so 300 feet. Okay. The height of a skyscraper, say, you know?
Okay.
Yeah, literally. Like, then this thing will basically descend out of the zip, come down, it'll take 10, 15 seconds, basically scanning the area as it goes down and perceiving like sort of this 2 meter square that it's trying to aim for, or 1 meter diameter square or circle, whatever it is. And it's aiming for that and basically checking at every point along the path that it's continually safe to do so. Yeah.
And one thing that I know you highlighted the doors before, but anytime I've seen this demoed for, you know, like our restaurant partners, they're like, well, like, what do I have to do to get my delivery?
Absolutely,
like,
yeah.
Like customers don't need to do anything.
No,
it leaves it behind.
No. So we have like basically 2 holes on this, right?
Yeah.
Like one at the bottom, so it's able to open the doors and then fly away. So that can happen sort of asynchronously. You don't have to be there to like walk over and open the lid or anything.
And that's safer.
And that's much safer, right? Because like we will request that you don't approach it naturally. So it'll just simply descend and the doors will open. We don't have a package in here right now, but we could do that.
Look to the magician's
I'm looking over
stage
there,
right. Yeah. And then describe the loading experience. So what happens at the actual restaurant or store?
Yeah, so this is like a kind of mock-up of this kiosk that we have. So this is also a very old prototype, so don't judge it. But this is a loading portal that we have, and this is intended to be sort of used at the initial stages of our deployment. So a customer is curious about like how would they interact with this, how would they fit this in with their business. This isn't like punching a hole in your wall and getting all the permitting required to do that. This is sort of like out in the parking lot to test it. So that's why it's sort of quite bare bones. But the zip will basically dock into a dock above there. Obviously this ceiling is only 9 foot tall, so we can't have that in here.
We can't fly off from here.
But it'll drop the droid through this, and so I'll simulate the experience. So it'll come down, basically land here, and this is a very old prototype. So, and then it'll open up, and we'll load it with whatever is necessary.
And it's quite like, this is like, I'm always amazed at how big this is.
The
I know
payload
Kieran
base,
talked a little bit about like what fits in here, but what are the actual like dimensions and payload for this?
Yeah, it's 13 this way inches. What's that? 330 millimeters. By
metric system. That was me.
I assume we have some non-US people watching.
Yes.
And so it's 13 by 10 by 9 high.
Okay.
Yeah.
That's a lot. That's
It's pretty high.
Bag of groceries.
Yeah, I only know the volume in liters, so I'm really mixing units here. So it's 20 liters of volume.
Amazing.
Yeah.
And then, sorry, did you say the weight it can carry?
And the weight is up to 8 pounds payload.
8 pounds.
Yeah.
That's
So-
quite a lot.
And how is it
3.5
connected
kilos.
to the zip? How does it lower from the zip?
Well, there's a cord again.
We're all quizzing you.
Yeah. I'm not sure where this prototype came from,
Yeah.
but there is essentially this guy, right? And this is going to be kind of tied to the zip and pulled up by the zip. Yeah. On a winch. Yeah. So the zip uses the same winch that it does for delivery, for kind of manipulating the droid within the kiosk, within the wall portals, and within the roof portals. So we're actually starting with 3 different versions of site infrastructure for this. Yeah.
So the winch controls up, down, and then the thrusters control lateral movement.
At delivery side. The thrusters don't do anything here, just for,
Correct.
it's so close to people, it's not safe to do that. Yeah.
During delivery, yes.
Yeah.
Awesome. Should we? Okay. I know I asked. I thought that fits like a grocery bag or so. But how many pizzas, Kieran?
So this would fit 2 small or medium pizzas. So 2 13-inch pizzas. So 4 of those half boxes.
Okay.
Plus room for drinks.
That
Or ice
feeds the
cream.
family.
And dessert.
That's it. Yeah.
That's great.
Exactly.
Speaking of, how's our temperature
Yeah, let's
test
go check.
doing? Are we ready?
Yeah.
Has it been 10 minutes?
So what I am.
That bag looks heavy. It really fits a lot.
So the pizza's still warm. And then I am very curious to see if the ice cream is still nice and cold.
That's frosty.
There's still ice on the outside, right?
We'll give you a visual test there. Okay, so that's cold. I need to...
So, the Droid, the material of the Droid does have insulative properties, so any payload is going to hold its temperature better than, say, just a paper bag on a, passenger seat. But even with that in mind, when we have hot and cold in the same Droid, those two temperatures don't negatively impact each other over the short distance of a flight.
Amazing. Well, that pizza looks good. I'm wondering who gets to eat it. Same thing with the ice cream. Is there anything else we haven't talked about that you think that our audience needs to hear that I haven't asked you about?
Well, my favorite detail, favorite detail about the Droid, and this is just like really good consideration. So the payload bay has a reverse draft angle, so the top is a little bit narrower than the bottom. So if it fits in the top, it should fit out the bottom. I just think that's very clever. Makes a lot of sense.
That is very clever. Yeah. Also, I remember hearing, I don't know if this is like a little UX-y story that, folklore. Is there something about like this click that was like added later that we felt like was an important UX thing? Do you know about that?
Yeah. The click is...
Putting
the
you on
click.
The spot. I heard a thing once.
Yeah, for sure. This is definitely something that's been impressed upon us, the importance of this. So the click really gives the audible cue. This is running a different version of software too, like our loading software. So we actually have LEDs on the side that do change color also
that tell you it's
with
closed.
that cue. Yeah, exactly. And the reason for that is it's just so important to the structural sort of case for this. Like the loads from this do run through that. So
yeah. You don't want the
we do require
Droid flopping around.
Yeah, and we sense that. We have like a double redundant sensor to detect if that's closed, essentially. And
Very cool.
Yeah.
Did you talk about the Paraland?
Yeah, the Paraland is definitely worth talking
we should
about.
Talk about redundancies and
Yeah,
features in general.
For
Yeah,
sure.
Paraland.
So, as I said, this is an aircraft unto itself, and exactly the same as with our Zip, sort of the mothership aircraft, we have a Paraland system, so a parachute. So Paraland being parachute in a tube with some sort of like expulsion device, and that's what we have here. This is actually lives just under here, and actually perforates kind of through the foam. I brought this.
So it kind of bursts out.
I brought this little piece of foam to sort of demonstrate what that is. So we have a little like a robot to stab this, and it actually bursts straight through this as the. So this like kind of pops out, and this. And then the parachute will basically be blown through that.
Is the robot that's stabbing that's inside of there? Is what you're
saying?
No.
The robot that stabs it is a piece of manufacturing equipment.
I see, when you design
it. Yeah. So we have as a point on our manufacturing line, we perforate that with a.
I know in our Zip there's like a little pyrotechnic to release.
Yeah, it's exactly the same in this.
So fascinating.
Yeah, it's exactly the same in this. So.
With a successful temperature test and like digging into all the design and engineering of the Droid and what goes into like amazing packaging and how you get a great delivery, I think we've covered everything.
That's a lot of it.
Yeah. So
Unless there's any questions.
This has been great. Thanks for joining us.